Welcome. Hope everybody's having a great time at the show. All right, well, my name's Jim Scott. I handle enterprise architecture for MapR. And what I'd like to talk about today is how to leverage the cloud. So, the cloud is pretty important these days, and in order to understand where we're at, it's helpful to kind of reflect back and see how we've gotten to where we are. So if we look back 30 years ago, relational databases were the early type of database that people relied upon. And for 20 plus years, they were the solution to every problem. Now, if you're like me, you've probably heard a lot of people in technology talk about using the right tool for the job. The problem is people typically don't use the right tool for the job. They use the tool that's easiest to get into a production environment to support their business use case. And that's okay, there's nothing wrong with it, but understanding that an option that's available and easy to get started with isn't always the best solution long term. So after we started picking up these relational databases, building applications for the enterprise, the internet really started to take a hold. The applications that we were building, they started looking different than those enterprise applications, right? They had to be able to support quicker response times. They had to be able to scale more broadly than the typical enterprise applications. And then with the advent of the internet and all of the changes it caused, we're now in this phase where we're starting to see a massive digital transformation occur. Now, if we look at this digital transformation from a business perspective, what we'll see is that really what's happening here is data is causing this massive disruption in the industry. These companies are founded on data. Without the data, they cannot create the rapid response to their customers. The data is what enables them to deliver a quick customer reaction to them, making product recommendations, getting feedback on properties, understanding that when a person says, I want to get a ride someplace, I can interact with them quickly, get a car to them, and get them to their destination. It's all about the data. And if we look at these companies in a broader view, what's really happening is newer companies can come along who are not mired down in legacy technologies, and they can pick these technologies up and they have a chance to disrupt the market. And because of the lower cost for the point of entry into these businesses, the amount of time it takes to build solutions on these newer technologies, they have the ability to quickly adapt to a customer-centric point of view and to truly impact an industry. Pretty much everyone out there realizes that if you have a customer-facing business, you have to be responsive to the customer. And what we see if we start looking at the industry leaders are they've got this legacy stack of technology they have to handle. And as more and more data continues to come in, they don't just have more money to spend. IT spending stays flat. If IT spending grew at the same rate that data grew, no one would care about the new technologies. They'd be happy staying with the old, but it just doesn't work that way. So as we see the new technologies picking up speed, we have to see this ramp down of spending on the old technologies. They move away from the legacy. Now, it doesn't mean the legacy is going to disappear, but we have to make the legacy work with all of the newer technologies. And within business, what we see happening is somebody says, I've got this problem, and I'm going to draw a box to represent my problem, because everybody naturally draws a box when they have a problem, right? So what happens here is someone in your company is putting pressure to say, we need to deliver more for our customers. So the pressure is coming in. And then they say, well, we have all of these V's related to data that are typically attributed with big data. But in actuality, if you have a problem that it takes more than one computer to answer in the service level time that you require, it's effectively a big data problem. So all of this pressure is coming in from all of the different data sources that you have, the total volume of data. And then someone says, boy, instead of spending all of this money on capital, shouldn't I leverage the cloud? Because it's a very inexpensive operating cost to leverage the cloud. It's easy to expand, but it's more pressure. And then for any of the incumbents, it's of course, but in addition to all of this, we have to integrate with legacy. This is a tall order. All of these things pushing in from all the different directions is a pretty major deal. So for us, this is an opportunity from MapR because we actually do support all of this. And I'll touch on this a little bit at the end, but right now, what I want to do is actually, I want to take a moment and pause, and I want to give everyone here an opportunity. I'm going to give a couple different pieces of terminology that I want to make sure everybody is fully aware of. Has anybody ever heard of data gravity? Just a couple hands. Okay. So data gravity is exactly what it sounds like. Data gets heavy over large volumes. So if you could imagine for a moment, I give you 10 gigabytes of data. That's pretty easy to move around, right? 10 gigs, who cares? Nothing. But if it's now suddenly a terabyte, that terabyte becomes a little bit more difficult to move, right? How long does it take you to move a terabyte of data, say from Amazon Cloud to Google Cloud Platform or Azure or Big Step or whatever your favorite cloud provider is? But if we take a step even further and say, instead of just a terabyte, it's a petabyte, it's a significant amount of time and effort that it takes to move your data around. And the cloud vendors are relying on data gravity to keep you in place. They want you to stay where you're at. The cost of you to get data into the cloud, anybody know how much that costs? Free. That's right. That's a great cost proposition, right? How much does it cost you to get your data out? They charge you by the byte. Every byte out, you have to pay for it. Easy to get your data in, difficult to get your data out. All right? So this is a really, really important thing when you start considering leveraging the cloud. And I'm not saying this to scare you away from the cloud. Really, truly, I'm not. Using the cloud is awesome. I'm a huge advocate. The other one here, though, is cloud neutrality. Now, cloud neutrality is really about you being able to use the cloud in a neutral way. At the end of the day, the fundamental baseline for the cloud is cloud providers like Google, Amazon, and Microsoft, right? We'll just call them the big three of the cloud right now. They are not now, nor will they ever, in my prediction of the future, ever call each other up and say, hey guys, we've got a whole bunch of really great customers here, and I'd like to make their cloud experience better. Can we agree on standard APIs between our cloud services so that our customers have freedom of choice? Right? It's never going to happen. The cloud has the potential to be the biggest vendor lock-in since mainframe. Because once you're in, you don't get out. And so the combination of data gravity and cloud neutrality are really major deals. So what I typically propose is leveraging the cloud as infrastructure as a service. It's infrastructure, use it, but don't necessarily be lured in by, oh, well, we have an API for that. We have an API for that too. And then the last set of terminology here is a container image and a container repository. So this is where we start looking at tools like Docker. And so when you build your software into Docker, that is a container image. And this container image is what you use to deploy your software on your infrastructure, whether it's on-premise, in the cloud, or in multiple clouds simultaneously. You depend on that container image. And the repository is where you store your image to enable you to have copies of your images in different places so that you can launch those containers when you need to. Are there any other terms that you've heard, cloud-related, that you say, you know, I hear people throw this word around or this phrase around, but I would just love an honest, straight answer about what this actually means. Does anyone have any of those? No? Okay. If you come up with one later, feel free to bring it up. Otherwise, if you just have one, you're like, I don't want to bring it up in front of everybody here, I'll be at the booth, MapR's booth right outside here, the rest of the day. Now, continuing on, anything can fail. Anything. Amazon S3, very popular. A large portion of companies rely on Amazon and S3. MapR ourselves, we use S3 for different use cases. Now, earlier this year, Amazon S3 went down and caused a massive outage for thousands of companies. Now, aside from this ops is hard, it should have been hashtag ops is hard because DevOps is extremely difficult. The takeaway here is not be afraid of the cloud, run away, don't trust it. It's that you need to consider everything. If you put all of your eggs in one basket and you drop the basket, or if you hand the basket to Amazon and they drop the basket, eggs are going to break. So my perspective is just because there is this cloud that has a tremendous amount of resiliency, and we now know that it can fail, we've seen it fail multiple times, your options are you can run in a multi-data center approach just like many companies do. Multi-data center, effectively in cloud terms, also means multi-cloud. So if you can build software and run it in any cloud without having to rebuild your software, that's a pretty compelling advantage for your business. And so when I used to work in digital advertising, we served up about 60 billion transactions a day. And we ran in the East Coast and West Coast of the United States. And on a sunny Saturday afternoon in the summer, I got a call that our data center on the East Coast was down. Why was it down? Well, we found out later that our data center provider accidentally turned the power off. Okay? They accidentally turned the power off. You cannot predict that someone is accidentally going to turn your power off. Data centers have generators to protect from power failure, but somebody flipped the switch on us. Whoops. But we ran multi-data center, and we lost nothing. We were a customer of MapR, and now I work for MapR. So, what I'm trying to convey here is always prepare for the worst and hope for the best. If you put all your eggs in one basket, just be prepared that something can go wrong, and when it does, you will suffer. As long as you understand the ramifications, it's okay. Not understanding the ramifications is the worst scenario you can be in, right? It's easy to put down on paper and say, here's the potential problems, and for someone to sign off and say, it's not worth it to us to run multi-data center. It's not worth it to run multi-cloud. That's okay, as long as you understand what the risks are. So to help explain this use case and how we run, I want to talk about Customer 360. So has everyone here heard of Clickstream Analytics? A few people. So Clickstream Analytics. It's effectively what digital advertisers do as you're traversing websites. They cookie you, they keep track of where you're at. They don't actually care who you are. They just want to be able to serve you advertisements. Well, the fundamental basics of digital advertising are the same things every business out there that has a customer-facing application can do for themselves to have faster, better response times and deliver a better experience to their users. So you can take the click stream and the activity stream. The activity stream is, how long was the person on a page? Were they scrolling down the page? Did they hover over your images? Right? And the clicks are, they actually clicked. So you can build your user profiles and you can store those in the database. Well, in our platform, what we do is we say, this is great running on Amazon, but I'm a firm believer in not putting all my eggs in one basket. So we can actually deploy this entire identical stack over on Google almost effortlessly. Literally the only thing we have to do is pay the bill. So instead of having 100% of our traffic and bill go to Amazon, we split it up and send part of the traffic over to another cloud. So our user profiles are the part that we replicate between the locations. So if you can replicate your user profiles by saying click replicate and not having to write your own data replication or database replication, that's a pretty compelling value proposition. And what we do here is we say our user-facing website and applications, they run in the cloud. But we actually have on-premise hardware as well. We already had an investment in it. We use it. We manage it. And because of this, I say, well, we actually apply our machine learning and build our own models on our on-premise data center because I don't want to spend the money on the cloud when I already have my on-premise investment and expenses in place. So we take those profiles and we take the click streams and we bring them down. So we can actually rebuild user profiles on-premise and replicate those back to the clouds. And in addition to that, we can take these user profiles, build new models, and run these models up in the cloud. So for example, having a recommendation engine running on your own website is very nice for your customer because you may have a lot of content on your website and maybe they're reading your blog. And at the end of it, maybe you want to put up a recommendation that says, if you enjoyed this, you might also find these other blogs or articles or whatever interesting. So having a recommendation engine, your own models on your website can be built and deployed this way. And so as more users come to your website, you may have a sales team, and your sales team wants to know, who are these people? What companies do they work for? Because I want to go talk to them, and I want to sell our product to them. And so you can actually take and do things like digital advertisers do, where multiple people from your home are browsing the internet. They call it householding. Well, this is kind of like enterprising. If 5 different people from this company are viewing our website, we can group them together and say, this company is interested in these topics. And then we can take that data and we can push it to our Salesforce tool. And so then our Salesforce team, that's the tool they use, and so now they have access to it. We didn't have to build a new tool for them. We just exported the data there. Now, this type of solution can be built with point solutions. The problem is point solutions is what has gotten us to this point of complexity. Point solutions are a pain to administer. Every point solution has its own security. Every point solution has its own data store. Every point solution has to be administered in its own way, and to get data between these different locations is a whole bunch of dotted lines up here. Every time you add a dotted line, there's complexity, there is latency. And so even if you take those out and you replace them with the web services that are available through the cloud providers, the data is still separate. You can't take the data from DynamoDB and store it in S3 unless you build an ETL process. You can't do analytics on them without moving them in different locations. If you want to do the data warehousing types of workloads, you've got to move your data into Redshift. So it's still data movement. It's still latency. And latency is the enemy of agility. If you want your company to be able to turn at any point and benefit from the platform you're putting together, the technology and the tools, you've got to be nimble. And fundamentally, at the end of the day, the circles are easy, right? I can spin up and write software fairly quickly. To download software, click, I've got a fast internet connection. It's down, install, run, build, great. But when you try to integrate that into the enterprise, when you try to deliver a service level agreement to customers, this is where the complexity comes in. So you can take all of these point solutions, you can put them in a box, but it doesn't actually converge anything for you. Point solutions are nothing more than that. They solve one specific problem. You still have to figure out how to solve all the rest of the problems. Now, when you look at leveraging the cloud, there are a few important things Well, if you're going to run in the cloud, you probably want to know where your data is, so you probably want to have location awareness. It would be pretty nice if you want to have a multi-cloud strategy. Not only did I mention before not having to rewrite your software against a bunch of different APIs to run on different clouds, but if I can access my data through a single global namespace, that's a pretty compelling argument to say, I can get at my data from anywhere. It simplifies my job. It makes administration easier. It makes security easier. And I don't have to worry about how to get access to my data or where it lives. I can find it very easily. And then omnidirectional replication. What I mentioned about the user profiles in that Customer 360, the internet works in very fun and interesting ways. My first request, I may end up getting served off of Amazon's website. My second request, I may get routed through another server that directs me to Google's cloud. Well, if that happens and I make a recommendation for a user on Amazon and they just read a page and now they get routed to Google, if I don't have their updated user profile, I might recommend to them the same page they just read. What kind of user experience is that? If you show your customer the page they just read as a recommendation, you look kind of foolish. So your user experience is critical. Omnidirectional replication, absolutely required for it. When we look at leveraging cloud with containers, we start seeing some significant benefit. Containers adoption has gone through the roof in the last 3 years. And if you look at some of the challenges with containers, it's very difficult to take an application and put it in a container and just make it work for everything you want. Traditionally, people focused on stateless applications, right? You can't save data inside of a container if you hope to keep it around. Because when the container dies, the data in the container dies with it. So some people say, well, I can persist my data to a relational database. Well, that's great 10 years ago. But the relational databases don't scale to the level that you need if you're going to go deploying a whole bunch of instances to have high availability and resiliency. So you start leveraging something like NoSQL database, maybe MapRDB, and you say, well, I can now persist my data. Well, there's usually another type of data that a lot of people forget about, which is logs. Web servers generate massive quantities of logs. Log shipping is one of the single most boring activities in any business. And yet it is absolutely critical to every piece of software out there. Being able to troubleshoot, perhaps even being able to do billing to your customers based off of logs. And with this approach, you've got the ability to generate the logs from within your container. You can direct those logs right through the standard file system API, which means you don't have to do any extra work. It just lands on top of MapR in this case. Your data is protected, it's highly available, and you now have access to do anything you want on it. You can do analytics immediately without having to do log shipping. So it makes your job easier. It lets you focus on your core competencies of your business, right? Who wants to spend time reinventing the wheel over and over and over? I don't. Just saying. And so what we see is there's a lot of opportunities here. And when you start taking these into consideration, this is where MapR says, well, if you really want to simplify your efforts, you want to deliver something that's better for your customers, the Converged Data platform helps because on the one side, everybody knows you can do analytical workloads with a big data platform. But our Converged Data platform brings in operational. So you can run the NoSQL database. You can run event streaming in the same place as your analytical workloads. You don't have to move the data. You don't have to transform the data into a different format. You can perform analytics on the data in place without having to suck it out of one cluster and into another. And with a document database here, it takes about one line of code for an engineer to persist their data to a document database. It takes about one line of code to get their data back out of the database. One line of code is a lot better than the hundreds or thousands of lines of codes it takes to persist your data to a relational database. And then when you combine these, you now have converged applications. If you've ever gone to a shopping website and purchased something in the past, and you say, boy, I'd love to buy another one of those. You go back, and you go to find your order history, and your order history is gone. Systems of the past, those operational systems, after 6 months maybe, your data will get rolled out to the data warehouse for archival, but you no longer have access to those purchases. Amazon is an example of all of your history is here for you to see, right? It doesn't make sense to deliver a customer experience that's less than everything. And so these converged applications have the ability to operate on both sides simultaneously. You can create feedback from all of the intelligence out of your analytics directly back into your operational state. And so MapR is founded on an open API architecture. So this whole platform is delivered through a series of open APIs. The first is the HDFS API. It's the only thing that is going to continue to live on from Apache Hadoop. It's the API. Amazon S3 was the first implementation outside of HDFS to leverage the API. We do the same. There's NFS and POSIX, which is a standard that's been around for over 30 years. Every business application can read and write files over these APIs. And then, of course, you want to be able to apply SQL and other APIs like HBase, which is column-oriented key value store. And then you've got JSON API, document database, and the Kafka API for event streaming. It's the de facto API for event streams. It's the fastest implementation on MapR. And so all of these things are great, but there's a handful of benefits I want to make sure are called out. These are all very important, but I really love to focus on the very last one. If you are trying to perform analytics on operational data, and operational data is constantly changing, try to run a SQL query against data that's always changing. SQL query will run fine. But when you run the SQL query a second time, what happens? It's querying different data. So being able to freeze it in a snapshot, a consistent point-in-time view of your data is critical for people building models, for running SQL queries, trying to build reports so that they can save their sanity. Because if the data's constantly changing, they don't know if the one change they made to their query changed everything else. And that happens in this platform. If it's 50 terabytes of data, it's instantaneous. The data size does not matter. It's not a copy of data. It's a point-in-time snapshot of the data as it sits. And so when you put the power of MapR into your business, there's a number of benefits here. Most people like to focus on reducing cost, but fundamentally growing revenues, building additional opportunity for your business, disrupting the industry. You have the ability to innovate and to benefit from the cost savings at the same time in the same platform. So with that, I will be at the MapR booth this afternoon around 2:30. I'll be doing a book signing for my new book, Microservices and Containers. If you'd like a copy, free, stop by. I'll be signing it later. If you'd like to go to the website, there's a PDF version you can download, or there's an HTML version you can read as well. That's everything I have. Thank you.